Okay, just reviewing what we did in class today, short methods of differentiation. If y equals some constant times x, for example, 2x or 7x or negative 5x, then dy dx is just the constant. Remembering that you're dropping a power of x when you differentiate. So for example, if y was 7x, then dy dx is 7. If y is negative 2x, then dy dx is negative 2. Okay. Also, if y is a constant, then if you differentiate a constant, you get 0. So if y is 10, for example, dy dx is 0. If y is negative 5, dy dx is 0. So if you differentiate a constant, you get 0. Now, if y is x to the power of n, then when you differentiate it, you bring the n to the front, you write down your x, and you drop this power of n by 1. So it's nx to the n minus 1. And also, if y equals some constant times x to the power of n, then dy dx, the derivative, is the constant times the derivative of x to the n, which is bring the n down to the front, x to the n minus 1, which is just k times n times x to the n minus 1. Okay, we're going to do some examples from exercise 8.5 from question 2 onwards. The first one is to find the derivative of this function. So to find the derivative of 2x plus 5 times x squared minus x plus 1. What you really want to do, we're going to let, say, y equal that, but we really need to expand this. It'd be really much better to expand this and simplify, and then we'll differentiate it. So if we multiply 2x by each of those terms in the second bracket, we get 2x cubed minus 2x squared plus 2x, and multiplying 5 by each of these terms, we get plus 5x squared minus 5x plus 5. So therefore y is equal to 2x cubed plus 3x squared minus 3x plus 5. So that's what y equals. So now to find the derivative, we do dy dx, and we differentiate this. So it's 2 times 3x squared for the first term, plus 3 times 2x is the second term, minus 3. When you differentiate minus 3x, you get minus 3. And when you differentiate 5, you get 0. Therefore, this derivative is 6x squared plus 6x minus 3. Okay, we're now going to look at question 3a from exercise 8.5. And the question is to differentiate the following. X squared over 6 minus x. So I'm going to let y equal that. So question 3a, differentiate x squared over 6 minus x. I'm letting y equal that. Therefore, dy dx is, now remember this 6 is just a constant. So I'm just going to keep it there, and I'm going to differentiate the 2x. You can actually write it as 1/6 times x squared if you want. Sorry. So remember, you can write it as, so your constant is 1/6, so you leave it there, then you differentiate your x squared and you get 2x. So it's 1/6 times 2x minus, I'm going to differentiate x, which happens to be 1x, so if you differentiate 1x, you get 1. So 1/6 times 2x, you get some cancelling here between, and you get 2x over 6, which is really just x over 3, minus 1. So that's what dy dx is. So question 3a. All right, we're also going to look at question 3f. And in question 3f, you're asked to differentiate the following. 2x to the power of 5 minus 3x to the 4 plus 6x cubed minus 2x squared all over 3x squared. Now, if we let that equal y, then what we're going to do, we're going to actually, each of these terms is over 3x squared. So I'm actually going to divide each term by 3x squared. So I've got 2x to the power of 5 over 3x squared minus 3x to the 4 over 3x squared plus 6x cubed over 3x squared minus 2x squared over 3x squared. Now this is still what y is equal to. We still haven't looked at dy dx. So simplifying, I get 2/3 x to the power of 3. Now the 3's cancel, minus x squared. 6 over 3 is 2, so we get 2. And x cubed over x squared is x. And minus the x squareds cancel, and we get minus 2/3. Now that is what y is. So now to work out dy dx, I just differentiate this function here. Okay, so it's 2/3 times the derivative of x cubed, which is 3x squared, minus differentiating x squared, we get 2x, and differentiating 2x, we get 2. So 2/3 of 3, they cancel, and leaving ones in their place, you get 2x squared minus 2x plus 2. So therefore, this is the derivative, 2x squared minus 2x plus 2. Okay, the next question is question 11. So given that v equals 4 on 3 pi r cubed, you're asked to find dv dr. Now, the v is in place of normally where the y would be, and the r is in place of normally where the x would be. So normally you'd be doing dy dx, but we've got a v here and an r there, so therefore we're finding dv dr. Now, notice that 4 on 3 is a constant, and so is pi. So 4 on 3 pi are the constants, and so to differentiate this, you just need to differentiate the r cubed. So we've really got v is some constant times r cubed. So dv dr is the constant times the derivative of r cubed, which is times 3r squared. Now we get some cancelling here, and we get 4 pi r squared. So therefore dv dr is 4 pi r squared. Question 12. If the function of x is equal to 2x cubed minus 3x plus 4, the question is to evaluate f-1. Now, before you can evaluate f-1, you're going to have to work out what f-x is, which is the derivative function. So the derivative function will be 2 times 3x squared minus, if you differentiate minus 3x, you get minus 3. If you differentiate plus 4, you get 0. So therefore, f-x is 6x squared minus 3. Now, if we want f-1, we're trying to find the gradient of this function when x is 1. So it's the derivative function, and we're substituting x equals 1 into the derivative function. So we get 6 times 1 squared minus 3, which is 6 minus 3, which is 3. And just for one more example from this exercise, question 14, and the question is, if y equals x cubed minus 7, to evaluate dy dx when x equals 2. Okay, so we know what the function is. The first thing we'll do is work out dy dx by differentiating this, and we get 3x squared plus 0. So if you differentiate the minus 7, you get 0. Now we will substitute when x is 2. We're trying to work out what dy dx, which means that we just substitute x equals 2 into this dy dx function. So we get 3 times 2 squared, which is 3 times 4, which is 12. Now, in the second part of the question, we're asked to find x when dy dx is equal to 12. So, we already know what dy dx is, and it's equal to 3x squared. And then we're going to substitute dy dx is 12 as well into this. So therefore we get that 3x squared equals 12. This means that x squared is 12 over 3, or that x squared is 4, meaning that x is plus or minus the square root of 4, which means that x is plus or minus 2. Okay, so you need to have both those answers there for x. So find x when dy dx is 12. You'll substitute that, you've worked out your function for dy dx. You know that this dy dx is 12, so you substitute that in there, and then you work out the values of x, noting that there are 2 values here. If you could now please do exercise 8.5, question 1, all of it, question 2, A to D, question 3, B through to E, questions 5 to 10, and questions 13 and 15. That's the end of this video. The next video is on some further differentiation and indices.